Welcome to Chapter 3, Part 2 notes. This will be 3.3, 3.4, and 3.5. So 3.3, our objective is to determine whether two lines are parallel, and the way that we are going to do this is by using the properties that we covered in the first part of Chapter 3. So let's review some of those properties and angle relationships. So the first one that we're going to look at here is corresponding angles. And remember, that means that they're in the same place with relationship to the points of intersection. And so we can say that A and B, our lines here, are parallel. Then angles 1 and 2 have equal measurements. And this should be because we're saying the angles, so they should have, the angles are congruent or their measurements are equal. And we can say that that's true by corresponding angles. Our second relationship would be the alternate interior angles. So on the opposite sides of the transversal and on the inside of our Z, so this is where our Z would be, alternate interior angles. So if these two lines are parallel, then 3 and 4 are congruent. Angles 3 and 4 are congruent, and that is by alternate interior angles. We can say the same thing for alternate exterior angles, opposite sides of the transversal, outside of the Z. Alternate exterior angles gives us, if these two are parallel, then 5 and 6 are congruent. By alternate exterior angles. And then finally, we have consecutive angles. Those are the same side interior angles. And so we can say that if A and B are parallel, then angles 7 and 8 are supplementary, and that is consecutive angles. And if they're supplementary, then that means the measure of angle 7 plus the measure of angle 8 equals 180 degrees, and that's by definition of supplementary. Okay, so let's see if we can use these, but now we're going to use them in proofs. So let's look at the proofs here. Number 1, we know that lines A and B are parallel, and the measure of angle 1 is 103 degrees. I'm going to go ahead and label that on my diagram. 103 degrees, and A and B are parallel. So in our proof, we start with what was given. Our goal is to find the measure of angle 2. How do we find the measure of angle 2? Well, if these lines are parallel, then angle 1 and angle 2 are alternate exterior angles, which are congruent. So we can say the measure of angle 1 equals the measure of angle 2, and that is by alternate exterior angles. And since the measure of angle 1 equals the measure of angle 2, then the measure of angle 2 must be 103 degrees. And that is by the transitive property of equality. In our second proof, we are given that A and B are parallel. The measure of angle 3 is 64 degrees. And then we start with that in our proof. That's our given. We want to prove the measure of angle 4 is 64 degrees as well. So we want to compare angles 3 and 4. So the comparison for angles 3 and 4 is that they are corresponding angles, which means that those two are congruent. So we say the measure of angle 3 equals the measure of angle 4, and therefore the measure of angle 4 equals 64 degrees by the transitive property of equality. All right. Number 3, we are given that lines A and B are parallel. Measure of angle 5 is 112 degrees. We want to prove that the measure of angle 6 is 68 degrees. So let's start with what we were given. A is parallel to B, and the measure of angle 5 is 112 degrees. Our next step, eventually we want a value for the measure of angle 6, which means we need to compare what we know with what we want to know. So what's the relationship between these two angles? We can say that angle 5 and angle 6 are supplementary, and that is because they are consecutive angles. And if they're consecutive angles and they're supplementary, then that means that their sum is 180. So the measure of angle 5 plus the measure of angle 6 equals 180. And that's by the definition of supplementary. Our next step should be, again, we're trying to solve for measure of angle 6. So let's substitute in the measure of angle 5. That's 112 degrees plus the measure of angle 6 equals 180. And that was by substitution. And again, solving for the measure of angle 6, I'd like to subtract 112 from both sides. So we're going to use the subtraction property of equality to say that minus 112 gives us the measure of angle 6 equals 180 minus 112 is 68 degrees. Let's take a look at the next page. Not only can we use parallel lines to find these congruences, but now what we can do is if we don't know if two lines are parallel, we can use these congruent statements to determine whether or not they are parallel. So sometimes we're not given that the two lines are parallel, but we can make the conclusion due to the converse, which means doing it backwards, of the theorems that we're using. So a converse switches the if-then. So for example, we've been saying if they're parallel and for example, if they're parallel and corresponding, then they're congruent. If parallel and corresponding, then congruent. So we could change that to say if congruent and corresponding, then parallel. Okay, so let's take a look at using that backwards. So we're going to use the diagram and we're going to determine if lines are parallel. So let's start with 3 and 8. 3 and 8 are alternate exterior angles. So the Z would be like this, telling me that lines L and M are parallel. If they're congruent, then they are parallel. L is parallel to M. 1 and 4 are congruent. Those are alternate interior angles. The Z would be here, and so we can see that line L and M are parallel. Angles 1 and 2 are congruent. Those are corresponding angles. And the Z would go this way, so we know that A and B are parallel. Angles 3 and 5 are congruent. Those are vertical angles, and so we have no conclusion because that does not make a Z, right? If angle 3 and 5 are congruent, that doesn't tell me anything about lines L and M or lines A and B. And angle 5, supplementary to angle 6, Those are consecutive angles. It should be vertical angles. Consecutive angles 5 and 6 make this Z, and so we need A and B to be parallel in order for that to be true. Let's try a few more. In the practice section, we want to find the value of x for L to be parallel to M. So in order for L and M to be parallel, these two angles must be corresponding and congruent. Corresponding, so 55 equals x plus 25. Subtract 25 from both sides. 30 equals x. On number 2, these are alternate interior angles. Alternate interior angles should be congruent. So if L is parallel to M, then 95 must equal 2x minus 5. Plus 5, 100 equals 2x. Divide by 2, x equals 50. Number 3, we have more than 3 lines here, so I'm going to go ahead and draw the Z. Okay, so we're looking at this angle and this angle. In order for L and M to be parallel, here's my Z. So that makes these, there's no special name for it, right? This is the one we need to do a vertical angle first, and then we'll be able to compare. Now, if I do this as a vertical angle, these two angles don't have a special name. If I do this as a vertical angle, these two angles will be consecutive. So let's do 105 here. So first, we did vertical angles are congruent. And then second, we're doing consecutive angles are supplementary. So we have 105 plus 3x minus 18 equals 180. 3x plus 87 equals 180. Minus 87. 3x equals 93. Divide both sides by 3. X equals 31. Okay, now our last one on this page, we have here, if L and M are parallel, these are alternate exterior angles, which means they should be congruent. So we have 3x minus 33 equals 2x plus 26 minus 2x plus 33. X equals 59. We don't need the degree symbol. X is not the angle, it's a calculation within the angle. So we don't need a degree symbol on that. Okay, let's take a look at 3.4. In this section, our objective is to relate parallel and perpendicular lines. So we've been looking at properties of parallel lines, and now we're going to look at how those relate to perpendicular lines as well. So perpendicular, remember, means that it makes a 90-degree angle. So perpendicular means it makes a right angle. And so we use the symbol of perpendicular lines. We don't have to put the, when we're putting the symbol for perpendicular, we don't put the box. Okay. So let's look at some theorems or postulates that we can look at. So if two lines are parallel to the same line, so here's two lines. Line A is parallel to line B. And then line B is parallel also to line C. Well, if B is parallel to C, they get the same parallel mark, and that means that A and C are also parallel. So if two lines are parallel to the same line, then they are also parallel. Okay. If two lines are perpendicular to the same line, so let's look at what that would look like. Here's A perpendicular to B. And then we have B is perpendicular to C. So if two lines are perpendicular to the same line, A is perpendicular to B, C is perpendicular to B, then A and C are parallel. If a line is perpendicular to one of two parallel lines, so it's really the same image, but I'll do another image here. So here are two parallel lines. A and B are parallel. And then I have here line C is perpendicular to A. Then C must also be perpendicular to B. Then it is perpendicular to the other. If it's perpendicular to one, then it has to be perpendicular to the other as well. Okay, let's try. If L is parallel to M and L is parallel to K, then which other lines are parallel? Let's start by drawing a visual. So here is line L, and we'll add in here is line M, and these are parallel. And then parallel to line L is also line K. If they're both parallel to the same line, then K must be parallel to M. Okay, I'd like you to try these, draw a picture for each one, and then state if A and D will be parallel or perpendicular. All right, our last part of the notes here, 3.5, and our objective is to use parallel lines to prove theorems about triangles and also to find measures of angles of triangles. So in order to find the measures of the angles of a triangle, we need to know a couple of properties about those triangles. So a triangle has three angles, and if we add up all three angles, the sum is 180. And I'll show you why in just a second. There's a special type of triangle called an equilateral triangle, and an equilateral triangle is also equiangular. And what that means, equal like equal, so the same angles. So it means that all three angles are the same. And if you have an equiangular triangle, that means that each of the angles is 60 degrees. Okay? Later on in the course, we will prove that all equilateral triangles are equiangular and vice versa. But first, let's show how do we know that the angle sum of a triangle is 180 degrees. And the way we do that is we start by saying, here's a triangle, any triangle, and we construct this parallel line. So we say, I'm just going to choose a line that's parallel to AC through point B. Okay, so we're going to say, let's make line PR through point B, and PR is parallel to AC. And why can we do that? Well, there are an infinite number of lines, and we're just choosing the one that satisfies these conditions, right? So I could make two lines with the same slope through any point, right? And so we're just choosing this line to be the one that's parallel to AC. And the reason we want to do that is so that now we can make two Z's, and I'll do them in two different colors. The first Z uses one leg of the triangle as its transversal, and the second Z uses the other leg of the triangle as its transversal. Okay, And what we have here is we've made two z's with parallel lines, and therefore we can use alternate interior angles are congruent to say that angle 1 is congruent to angle A, and angle 3 is congruent to angle C. And now we can see the sum of the angles in triangle ABC make a straight angle. Right? If we take angle 1 plus angle 2 plus angle 3, angle 1 plus angle 2 plus angle 3 makes a straight angle. So that's an informal proof of the angle or the triangle sum theorem. Let's do some examples. Example 2, part 1. Find the value of x and explain. Well, we just said if we add up all the angles, they should equal 180. So we can say 71 plus 67 plus x equals 180. 71 plus 67 is 138 plus x equals 180 minus 138. X equals 42 degrees. X is the angle, and so the value of x is in degrees. Number 2, we're looking at another triangle, and now I have all three angles that should add up to 180. I should put an explanation. Triangle sum theorem. Triangle sum, THM for theorem. So if I add all these up, they should be 180, 3x plus 10 plus 6x minus 28 plus 2x equals 180. Collecting like terms, we get 11x minus 18 equals 180. 11x equals 198 plus 18. Divide by 11, x equals 18. This time we're not labeling it degrees because x is not the angle measure. X is part of the angle measure. Part 3, we're looking at three angles within a triangle, and that tells me I can use the triangle sum theorem, which means that 8x minus 2 plus 5x minus 5 plus 7x plus 7 equals 180. Collecting like terms, this gives me 20x plus 0 equals 180. Divide by 20, x equals 9. This time we're not looking for x, we're looking for the smallest angle, so we need to substitute this back in. So we have 8 times 9 minus 2 gives us 72 minus 2 is 70. 7 times 9 minus 2, so that's 63 minus 2. Sorry, it should be a plus 7. Plus 7. There we go. 63 plus 7 is 70. And our last angle here, 5 times 9 minus 5 equals, that's 45 minus 5 is 40. So 40 degrees is our smallest angle. Looking at number 4, we want to find the value of x. Can I add these up to equal 180? We cannot because these are not angle measures. So we cannot use the triangle sum theorem here because they are not angle measures. These are side lengths. So how can we compare them? Well, notice there are these little congruence marks. which says that I can say 3x plus 4 equals 5x minus 8 minus 3x plus 8. 12 equals 2x, x equals 6. And then in number 5, we'd like to know which of these cannot form a triangle. How can we tell which ones will form a triangle or not? We need to add them up. So if I take 34 plus 62 plus 84 equals 180. 45 plus 63 plus 62 equals 170. That is not a triangle. 27 plus 51 plus 102 gives 180. And 35 plus 71 plus 74 equals 180. So it was only B. B is the only one that does not form a triangle. Let's look at the next page. Okay, our last property for this section about angles is that if I have a triangle, then we have this angle that we can make on the outside of the triangle. And the angle on the outside of the triangle is called an exterior angle. So an exterior angle of any polygon, so that's a triangle or a quadrilateral or any number of sides, is an angle formed by a side and an extension of an adjacent side. So what does that mean? It means I took one of the sides and I kept going, and the angle that's formed between the polygon and that extension is the exterior angle. Okay. And one of the properties of this is that the angle on the outside of the triangle and the two angles on the inside that are not touching it have a special relationship. And so we call these angles that are not touching that exterior angle remote interior angles. Remote meaning far away. So like a remote control for a TV, for example, works from far away. So a remote interior angle is an angle that is not touching the exterior angle. Okay? And the theorem that we have is that the measure of the exterior angle of the triangle, so that's angle 1 here, is equal to the sum of the measures of the two remote interior angles. So that says angle 1 equals the measure of angle 2 plus the measure of angle 3. Let's do a couple of examples. In example 3, part 1, we'd like to find the value of y and explain our reasoning. So we say, okay, notice the bottom of this triangle keeps going. That makes y an exterior angle. So we can use the exterior angle theorem, which says that y equals the sum of the two that it's not touching, 70 plus 88. Then y equals 158 degrees. On number 2, we're looking at the same thing. We have an angle here that's created by the extension of this triangle. And so we can use the exterior angle theorem. And it says that the exterior angle, the one on the outside, is 3x minus 9, is equal to the sum of the two on the inside that it doesn't touch, x plus 73. Solving for x, minus x, plus 9, 2x equals 82, divided by 2, x equals 41. We didn't want x, we wanted the measure of a, so then we use substitution back into a. Measure of angle A equals x, which equals 41 degrees. Example 3, find the missing angles and explain. So here, let's call it x. We need to find the measure of this angle. Well, if we look at this, we have two parallel lines and a transversal. So if this is the angle I want to find, this is the transversal I want to use. And so we say, here is my z. Notice I had to create the extension of that angle. And so now we can see that this is a corresponding angle to angle DCE. So we said first, corresponding angles. And then second, we can say, hey, I have 3 angles inside of my triangle. This is the triangle sum theorem, which says that x plus 98 plus 43 equals 180. 98 plus 43 is 141 equals 180 minus 141, x equals 39 degrees. And our last one before you have some try this problems, number 4, find the missing angle. We do have to do several steps before we can find this, but let's call it x. So I have an exterior angle. In order to calculate an exterior angle, I need the 2 remote interior angles, so I need this one. But in order to find this one, I need this one. And in order to find this one, I need this one. Okay, so notice we tried to find x, but in order to find x, we need more information. So let's start with, hey, I have vertical angles here. Vertical angles are congruent. So start with vertical angles. There's 45 degrees. Okay, so if I have 2 angles in a triangle, I can always find the third. And I can do that by using the triangle sum theorem. Do 180 minus 60 minus 45, which gives us 75. And now I have 3 angles that make a straight angle. Those have to add up to 180. So again, I have 180, but now minus 75 minus 68. And that gives us 37. And finally, we have the 2 remote interior angles. So we can say that x equals 100 plus 37. So x equals 137. And I'll go back and write step 3 was a straight angle. And finally, step 4 is the exterior angle theorem. Okay, the last page has some try this problems. So try these 4 problems and we'll go over them during our next synchronous class.